One of my favorite lessons, transforming formulas. We are in lesson 4-7, and we're solving formulas for a given formula. So I'm a little bit behind in my highlighting. So if I'm solving for H in example 1, notice it says S is equal to 2 times R times pi times H. And I'm solving for H. How is 2 pi R connected with H? It's all connected with multiplication. So if it's connected with multiplication, I'm going to divide each side by 2 pi R. Notice the R's cancel, the pi's cancel, the 2's cancel, and H is equal to S over 2 pi R. So it's kind of exactly like what we were doing, but instead of having numbers that actually add, we have a bunch of things that maybe won't add and subtract. All right, the next one, they're telling us to solve for H again. So I like to highlight or underline what I'm solving for. There's only one, oh, that's not a highlighter. There's only one H. So the first thing I have to do is get rid of this half right here. I'm going to get rid of that half by subtracting 2 pi R squared to each side. So notice all of this cancels out, and I have S minus 2 pi R squared is equal to 2 pi RH. And just like we did in the first example, if I'm solving for H, that's right here, and 2 pi R is connected by multiplication, I have to divide by 2 pi R from each side. Now, I'm running out of room, I apologize, but notice the R's cancel, pi's cancel, and 2's cancel. So my answer becomes, I'm going to write it in pink over here, it becomes H is equal to, and I'm just writing this H on the left side now, S minus 2 pi R squared all over 2 pi R squared. Now we're not going to get into the logistics of all of this yet, okay? But remember that in order for these 2 pi R squares to cancel, there would have to be one over here too. Okay, so we're just going to leave it as is for now in Algebra 1, and we'll get to the canceling a little bit later. All right, hopefully I won't run out of room on this one. In this case, we are solving for R. The R is right there. So the first thing I have to get rid of is this S squared. It is a positive S squared, so I'm going to subtract S squared to each side. So I have A minus S squared, because these cancel out, is equal to 2RS. Again, we're solving for R. R is connected by multiplication, so I have to divide by 2s. So notice the 2 and the s cancels out, and R is equal to A minus S squared all over 2s. And again, we cannot cancel out this s, sorry, I meant to do that in yellow, this s and this s, because we'd have to have an s over here as well. All right, continuing on, we're solving for H. How is H connected with pi R squared H? It is being multiplied, so I'm going to divide the whole thing through by pi R squared. What I do to one side, I do to the other. I'll keep the H on the same side this time. H is equal to V over pi R squared. All right, if you get nothing out of today, I do want you to star circle highlight this one because I want you to know how to do it, so make sure it's star circle highlighted. Notice we're solving for A. This is a little bit of a tougher concept, but you'll be really good at doing this soon. And notice now I have 2 A's. So we have to do what we call the opposite of the distributive property. And I believe we've talked about this enough But you guys know that this is also called factoring. Factoring. So I am going to take these A's out and make them 1. And notice what I have left over is B plus C, and that's all equal to Y. Now, I'm going to continue and finish this problem, but I'm going to talk about why we can take 2 A's and make them 1, but I'll do that in just a second. Let's revisit. We're solving for A. How is A connected with B plus C in parentheses? It's being connected with multiplication. If it's being connected with multiplication, I can go ahead and divide by B plus C. Notice all of the B plus C cancels out, and A is equal to Y over B plus C. Now, one thing that people really get frustrated with is how did this 2 A's become 1? So let's go back to the basics of the distributive property. You first learn the distributive property when you have like this. And notice you take this and multiply, and take this and multiply. Now I'm going to write it out as, I'm going to write it out as 2 times 4. I know that's 8. But notice how these 2 2's become 1, because now we're just going backwards. We're taking the 2 2's and turning them to the 1. Let's look at that with variables. What if I have an x and I have a 5 plus y? If I have to distribute this x through, notice my 1x becomes 2 x's, and you have no problem with it. But when it comes to factoring, you guys don't like to see it as much because you, for some reason, get really uptight as how we have this these 2 A's that become 1. So remember, because of factoring, because of the opposite of the distributive property, we can go ahead and factor out this A and have the B plus C together. All right, we're going to try this challenge one real quick. Ooh, it's telling us to solve for A. Sorry, I don't have that written here. So the first thing I'm going to do is I'm going to cross multiply. Notice I have x times A plus B is equal to AB. We're still solving for A. Notice I have 2 of them. But I want to go ahead and distribute the x through. So I have AX plus BX equals AB. Still solving for A. I still have 2 of them, but the problem is they're on the opposite sides of the equal sign. So I want to get this guy over by subtracting it. They're not like terms, so BX is going to equal AB minus AX. I'm solving for A. So now I'm going to do the same thing that we did before. I'm going to factor out that A. And when I factor out that A, I have BX is equal to A times B minus X. What are we solving for? A. How is A connected to B minus X? Through multiplication. So I'm going to divide. All of this cancels, and A is equal to BX over B minus X. All right, we'll talk about the logistics of reducing in another video, so we'll work on that in another video. Great job today. Don't forget to like and subscribe.